Exponential functions, the basics. An exponential function f with the base b is defined to be f of x, the function of x, equals b to the x power. So the base is a number, the variable is the power here. Or y equals b to the x. Y and f of x are the same thing, right? Where b is a positive constant other than 1, so it's greater than 0, but it cannot be 1, and x is any real number. The irrational number e is called the natural base. The function f of x equals e to the x is called the natural exponential function. E is approximately 2.718281827. It doesn't repeat itself. It just goes on and on and on forever. Scientific calculators have a button for E. So the characteristics of the exponential functions of the form f of x equals b to the x. The first thing is the domain is everything, right? X can be any real number, so negative infinity to infinity. The range is 0 to infinity in this form. If you have a positive number to a power, it can't go negative, and it also cannot be 0. It passes through the point 0, 1, so the y-intercept is 0, 1. There is no x-intercept, right? If the range is 0 to infinity but don't include 0, then it can't be on the x-axis there. If b is greater than 1, it increases from left to right. So it's going to be something like this. Well, that's pretty terrible. It's going to be something more smooth of a curve there. All right. Larger value of b, steeper the increase. And then if 0 is less than b, is less than 1. So if b is between 0 and 1, it decreases. So it's going to come down like this. Okay. And again, the smaller the value of b, the closer you get to 0, the steeper the decrease. All right. So the function is 1 to 1. That just means that there's exactly one y for every x. So, sometimes your y's can repeat themselves for functions, but the x never could. On a 1-to-1 function, nothing repeats. So if x is 4 and y is 7, it's always 4 maps to 7. 4 goes to 7. 4 goes to 7. 4 can't go to, or something else can't go to 7 either. If you have y is 7, you know it's 4. It's one y for every x, and that's it. The inverse function exists, and then the x-axis is a horizontal asymptote. So if we look at this is my between 0 and 1. This is my bigger than 1. Here's my horizontal asymptote across here, right? So even tried to color code them for you, the red, the blue, and the green there. All right. So that's not one graph, y'all. This is one graph, and this is a separate graph over here, okay, of what happens. So the blue is one graph, the red is one graph, but they both go through the point 0, 1. Now, you can, stretch this out and shrink it down, and you can shift it left and right and up and down and all kind of things and do reflections or whatever, just like you can with any other function. So don't get caught up and think that everything that has an x to a power has to go through the 0, 1. No, if you subtract 1 or if you do x plus 1 in the power or do something like that, then it may change where that is. I'm just talking about the basic function. B to the x power goes through 0, 1. All right. So find the following using a calculator. Okay, find the following using a calculator. So you want to have a scientific calculator. You want to be able to raise something to a power here. All right. So hit it on my calculator, 7, hit the power button, hit 2.3 equals, and 87, what did I say, round to 4 decimal places. So 8467. 846, and the next number is a 0. So 87.8467 is 7 to the 2.3 power. All right. And let's think about this. Does it make sense, right? You plug something in your calculator, you automatically think, oh, it's right. No, the user has to know what they're doing too. So 7 squared is 49, and 7 to the third power is 300 and something, right? So, okay, yes, 80-something makes sense to be 2-point-something power. That makes sense. So here's E. Now E, remember, that 2.7, and it's 1827 thing to the 1.6 power. So let's just see. So 2.7 and not quite squared. 3 squared is 9, so we would expect this to be less than 9 for sure. Let's do this. And I even have an e to the power button on my calculator, so I think I put in the power and hit e to the power, and that's exactly what happens. So this is going to be 4 point, and the 4 decimal places, 9530, and then another 3. So then it stays at 0 there. So 4.9530. And this is just practice putting this in. So on the particular calculator I have in my hand right now, I have to have the power in there, and then I hit the E button on it, okay? Some of you, it may be a second, it may be yellow and be a second, or it may be blue and be a shift, or it may be green, whatever. So you just have to learn how to use whatever calculator it is you have, but there is an E to a power button or E button on every scientific calculator and graphing calculator, depending on if you're allowed to use those or not, okay? So let's see. Put my power in a 0.23, and somewhere I should have on this calculator a plus minus, and I'm looking for it and can't find it. There it is. All right, and then e to the power. So to 4 decimal places here is going to be 0.7945. 0.7945. 0.7945. And then 2.7 times 3.1 to the 1.23. Bunch of 1, 2s, and 3s, and then I got a 7 thrown up in there. What's being raised to the power? So what you have to do first is this part. You have to do that part first. So we have to say 3.1, raise it to a power, 1.23 on mine, I have to equals. So that's going to be 2.7 times 4.0213778. And if I round it, it's going to be a 7 after that. But I'm not going to punch in my calculator what I wrote down on the piece of paper. It's already in my calculator, right? And the other thing is, like, my calculator is showing me maybe 15 decimal places. Guess what? It's probably going out to 128 or 256 or something like that. Probably some power of 2 because of binary. But it's going way, way, way out there, much further than I'm seeing it. So always use the stored calculator in your stored value in your calculator if you're in my class. Now, if you have another professor, teacher, instructor, you definitely want to find out what they want you to do. I do not want you to round this until you get to the final answer. So I have this thing. It actually goes way further than this in the calculator. So I'm just going to hit the times button and hit 2.7 equals, and then I get my value that I'm going to round off to 4 decimal places. 10.8577, and the next digit is a 2. So that 7 stays 7 there. So 10.8577 is that value rounded to 4 decimal places. But again, don't round this unless you are told to by your teacher, instructor, professor. Okay? Because you're in their class, right? Do what they want you to do. They're the head honcho. They're the one in charge. All right. So here, given the following exponential function, complete the following table of coordinates and graphs. So look, I'm giving you x values, -2, -1, 0, 1, 2, f of x. So we know already 2 to the x power, 2 is bigger than 1. This thing is going to go through this point, and it's going to come up and go this way, right? It's going to be that basic shape. I just missed this point right here, right? But so let's just see what happens. But before we even do that, let's just find these values. Let's find all these values and plot them over here, okay? So I'll find each one with a different color here. So -2, so this is going to be 2 to the -2, which means 1 over 2 squared, which is 1/4. So at -2, it's 1/4. -2 and 1/4 is way down here, real close to 0. Okay? So there's me a point. And then let's see, let's go to the next one. 2 to the -1 means 1 over 2 to the first, which is just 1/2. So at -1, it's a little bit higher up here. It's -1/2. It's right in between 0 and 1, right? Okay, well, let's just keep going here. Let's do yellow for this one. This is 2 to the 0 power. Anything to the 0 is what? 1, which we already knew that. 0, 1, we knew that was going to happen. It's going to go through that point. And so we keep going here. Let's take this nice fuchsia pink color here. 2 to the first power is 2. There's 2. So 1, 2, 1, 2 goes to that point. And it's increasing like it said it was going to do, isn't it? And let's see. I just got to pick me another point here, another color here. Let's pick this purple here. This is going to be 2 squared, which is 4. So at 2, it's 4. So 2, we go all the way up to 4, and here it is. You can see what's going on here. And we may even could go out further if we wanted to, but my grid won't hold it. So we're going to start. I don't want to start right there on that. I don't want to be touching it. I'm going to come out here, and it's going to get a little bigger, and it's going to come out and take off. Okay? So it doesn't ever touch this right here. It's an asymptote, right? And then it increases, and the further out you go, the steeper it gets, the more it increases. So, again, that's just graphing one of these things. Again, you could change this. This could be 2 times 3 to the x minus 1 plus 4, okay? Then when you plug in -2, -1, 0, 1, 2, you may not go through the 0.01, but it's going to have the same shape. The shape of it is going to either be this, if it's bigger than 1, or if it's between 0 and 1, that's going to be the shape of it, okay? So it's going to have the shape the same, all right? So I hope this helps you with exponential functions. Exponential functions.